Geometry. We're in Transformations chapter. It's the second section of notes. And we are focusing on symmetry. So what does it mean to carry a shape onto itself? It means the shape has symmetry. What types of symmetry exist? There is rotational, point, and line, also known as reflectional. So line symmetry or reflectional symmetry. What's the definition of line symmetry? It's a figure that can be mapped onto itself by reflection. So in these next bunch of figures, we're supposed to determine how many lines of symmetry does each figure have. This figure here has one line of symmetry. And that line of symmetry is this line right here. If you were to reflect this A about the line of symmetry, you would find that this point would end up becoming here, this point end up becoming here. In other words, if you reflected over that line, you would never be able to tell that it was reflected. It'd look exactly the same. How about Z? Does it have any lines of symmetry? No. No. Maybe. Look at this diagonal. No. It looks like maybe on the diagonal, but if I draw this diagonal and I draw a point from here to here at 90 degrees and draw that point again, I should end up being on this, on that Z. This one has none, has 0 lines of symmetry. How about this butterfly? Now, I'm not trying to trick you. If you look closely at this butterfly, I'm going to sneeze, darn it. Hold on a second, I'm sorry. What's happening? Oh, that was wet and wild. Anyhow, I'm not trying to trick you. You can see this has an antenna on the left. There's no antenna on the right. I'm not trying to get that fine a detail of this picture. So what I'm saying is you can ignore the fine detail. That might not even show up on the copy that you have. This has one line of symmetry right down through the center. Not trying to trick you. This next figure, there's no line you could draw through that, in which if you reflected the figure over that line, it would be the same figure. This flower has 6 lines of symmetry, and they're already kind of marked for you here. 1, 2, 3, 4, 5, 6 different lines we could reflect it over, and you'd never know it was reflected. The square has 4. 1, 2, 3, 4. 4 lines of symmetry. You could reflect it over any of those or all of those, and the figure wouldn't even be able to tell that it's moved. This one, some folks think, well, maybe on a diagonal. But on this diagonal, it wouldn't work, because if I try to draw this diagonal, to reflect, it has to hit this at 90 degrees. Same length on the other side, it would have to be a point here, but there's no point over there. This is a 0. Once again, we're just looking at line symmetry right now. This one is a no as well, and that's because this shape here doesn't have symmetry to it. This arrow has one line of symmetry going through the middle. These hearts of circles has 1 as well. It's that horizontal line I just drew. This one has 2 lines of symmetry. This vertical one and this horizontal one. This B has 1, a horizontal going right through the middle. This rectangle has 2. It's a vertical one and a horizontal one. This triangle has 3. If you draw the altitude of each of these angles, each of those are going to be a line of symmetry. This heart has 1, a vertical going down through the center, 1 line of symmetry. And this funky thing has 0. If you look at the way this is designed, there is not symmetry on any of those corners. All right, this next part of the notes, there are many correct answers for this, so do not think that you have to do yours the same way I did mine. Shade each figure so that it has the indicated number of lines of symmetry, so that it has exactly 1 line of symmetry. Well, if I were to shade just simply this, there'd be 2 lines of symmetry, which I don't want. There'd be this line and this line. So what if I did this and this? 1 line of symmetry, that works. Not a symmetry, not a symmetry, not a symmetry. So I'm going to stick with that. Number 2, 2 lines of symmetry. I'll just do what I did first on the last one. This right here has a horizontal and vertical line of symmetry. Exactly 4 lines of symmetry. So we want this figure as symmetric as possible because that's the most we can get out of this square. Someone else might come along to this and say, I'm just going to color in every square. That would work. This next one, 4 lines of symmetry. The middle one is colored in. I'm going to color in all the corners. That has 4 lines of symmetry. What are characteristics of a polygon that produces the maximum number of symmetry for its number of sides? Well, to maximize the number of lines of symmetry, the polygon is a regular polygon. That means all sides are congruent, all angles are congruent. That's what a regular polygon is. All right, on the back, it gets a little more specific, a little more complicated. Rotational symmetry has an angle of rotation and an order of rotational symmetry. Rotational symmetry. A geometric figure has rotational symmetry if the figure is the image of itself under a rotation about a point through any angle whose measure is between 0 and 360 degrees. 0 and 360 are excluded from counting as having rotational symmetry because it represents the starting position. In other words, you can take any shape and rotate it 360 degrees about its center and it ends up being in the exact same spot. Technically, that's not rotational symmetry. Angle of rotation. When a shape has rotational symmetry, we sometimes want to know what the angle of rotational symmetry is. To determine this, determine the smallest angle through which a figure can be rotated to coincide with itself. This number will always be a factor of 360. In other words, you can divide 360 by that number and it goes evenly. Order of rotation symmetry. The number of positions in which an object looks exactly the same is called the order. When determining the order, the last rotation returns to its original position. Order 1 implies no true rotational symmetry since a full rotation of 360 degrees was needed. Let's see if we can make sense of all that stuff. And the best way is looking at some examples. Does this figure have rotational symmetry? Let me try to illustrate this for you as best I can. Could I take this and rotate it so that it ends up being on itself? Sure can. Can I do it again? Sure can. Can I do it again? Sure can. I did it 3 times. Now I'm back to where I started. Took me three different rotation and stops to get back where I started, so the order is 3. What's the angle of rotation? Well, there's 360 degrees in a complete rotation. I just did that 3 times, not a complete rotation, but I went and stopped 3 times. So if I take 360 divided by 3, I'm going to get 120 degrees. This next one, this S, if I try to rotate it, not on itself, not on itself, not on itself. Looks like I just got it on itself there. So it looks like I stopped halfway and then I went all the way around to finish it up. So I think this angle of rotation is 180. You rotate it 180 degrees. Let me change the color a little bit. Let me add a blue up there and a purple down here. If I rotate it 180 degrees, I got it on top of itself. Now the purple's up top and the blue's on the bottom. If I rotate 180 again, then I get blue back on top and purple on the bottom. So the angle of rotation is 180 and the order is 1. This little fellow here, this would be an order of 3. It's 3 unique parts, which then stands to reason 360 divided by 3 is 120. Let's do this next one. I'm just going to add a 1 up here so we know we're back to the beginning. So I rotate, not on itself, not on itself. Oh, now I'm back on itself, but the 1s are in opposite corners. Keep rotating and I get back to the original shape. So I rotated it 180 degrees and it was on itself, which means the order is 2. So if I didn't make it clear, let me make sure this is clear. The angle times the order is 360 every time. So if you can figure out the angle of rotation or the order of rotation to figure out the other part of it, it's easy. You just take that number and divide it into 360. Do these ones on your own, stop the video, and then see if you and I agree with these answers. This figure here, I got angle of 120, order of 3. Angle 120, order 3. Angle 72, order 5. This one I got had no rotational symmetry because this part of the Z is smaller than this part of the Z. Shade each figure so that's indicated angle, I should say, of rotation, not or, so that it has the indicated angle of rotation and order of rotation. So angle of 180 and order of 2. Well, if I simply shade in this here, and I rotate this 180 degrees, it's going to put this on top of this and this on top of this. That makes sense. This one below it, if I shade this bottom corner and rotate it 180, this is always going to be in the center. 180, this would come here and this would come here. Makes sense to me. Angle of 90 degrees, order of 4. If I darken those in, I rotate 90 degrees, that puts this here. 90 more, 90 more, 90 more. Checks out. This last one, and once again, there's different ways to do this that are correct. These are just sample answers. If I rotate this 90, and then 90, and then 90, and then 90, and this stays where it is, that checks out. Point symmetry. Point symmetry exists when a figure is built around a point such that every point in the figure has a matching point that is the same distance from the central point, but in the opposite direction. A simple test to determine whether a figure has point symmetry is to turn it upside down and see if it looks the same. A figure that has point symmetry is unchanged in appearance by 180-degree rotation. You will notice that the point of rotation is the midpoint between every point in its image. So this has point symmetry, or this is the point of symmetry, because if you take the pre-image point and the image point, it goes through that center in each case. This has point symmetry, because if you take every line of symmetry, they all intersect in the same location. It says point symmetry. I shouldn't say lines of symmetry. I could say that, I guess. If we take each point from its image and pre-image and connect them, they all intersect at the same point, point symmetry. Same with this last one. Please do the assignment, form T.2. Have a good one.